So you can go to joinpd.com and enter this code CENMRM. So we'll just wait for a couple of minutes. Let others also join. So all of you who have just joined the session, please go to joinpd.com and you can see on the top right hand side, you can see a code CENMRM. Please type the code, use this code to open the session. Okay, so I could say some 50 participants here. All of you have joined, have opened this joinpd.com. Okay, so let's start the session. So all of the new people again who have just joined, please go to joinpd.com and you can see the code on the top right hand side corner screen, CENMRM. Please use this code to open the periodic slides. Okay. So today's week 3 credits all with us. So this is our first problem here. The problem says you have a random variable x and the random variable y. Both are independent. Their means are given to you, where mean of x is equal to 5 and mean of y equal to 10. And their variances are also given. So here the variance of x is given as 1 and variance of y is given as 2. So you have to find the value of variance of x into y. So one hint has been given to you in the problem that says if x and y are independent, x square and y square are also independent. So just assume this factor that if it is given that your random variable x and y are independent, so x square and y square are also independent. assume this fact and use this fact to solve this problem to calculate the variance of x times y. Is the problem statement clear? I can already see 2 responses here. And okay, almost half of the people have opened this joinpd.com. Please go to joinpd.com and use this code so that you can also participate in the session. Okay. I will give you some 3-4 minutes to solve this problem. We'll look at this problem again at 6:10. Okay. So if you have any doubt in the problem, please let me know.
Ma'am, I just had one question.
Yeah, please.
Are we doing graded assignment for week 3?
Yes.
Because the last date was the 27th May actually.
Yes, right. So the previous week session has not been scheduled, as you all know, because of the paradox. So today we are doing Solve with Us, but tomorrow there is another session that is scheduled for open session for week 3.
Open session or concept
So-
discussion?
Concept related, anything is.
So, sorry, I just joined midway through this discussion. So, does it mean the assignments have to be submitted on Friday?
Yeah, the deadline is Friday. You must
Okay.
have the deadline, yeah?
Okay. Sorry. Thank you for the clarification. That's a relief. Thanks.
So for now, please solve the question that is shared on the screen, okay?
On it. Thank you.
And if you haven't joined the join peer deck, please use joinpd.com and use the code to open the session.
Sure.
Okay, so I could see only 19 responses so far, and only 47 people have open join PD. Can others also go to joinpd.com and start answering there? Okay, so let's not spend a lot of time in this problem. So before we go to the responses, I want to know if there is any doubt, clarification you did. Anyone? Is the question clear?
Yes, ma'am.
Okay, because I could see only 28 responses here. All right, let's see.
And because I think many of us haven't gone through the content yet.
Yes, ma'am. Because of the paradox thing, we were there, so we couldn't complete the videos also.
Yes, ma'am.
So you should start doing it fast because next week is our quiz also, right?
Yes, ma'am.
Let's not get distracted. Okay, so I could see a lot of people have answered 25 and some 125. Okay, so we'll go quickly through the solutions. So we had to find the variance of xy, right? So what do we write the variance of xy is a random variable here. Now for any random variable x, right? If we have to find the variance, what we do is we find expected value of x square minus expected value of x whole square, right? So again here, in place of just one random variable x, we have two random variables. We are dealing with two random variables here. That is xy, product of two random variables. So in general, your xy is a random variable. So if we have to find the variance of xy, what we will do is we will find the expected value of this random variable xy square minus we will find the expected value of xy and we square it up. Fine. And since if you look at the first step here, so from the first step, we can write this xy expected value of xy square as expected value of x square into y square, right? And the second term here, that is expected value of xy whole square. So since x and y are independent, right? So if x and y are independent, we know that we can write expected value of xy as expected value of x times expected value of y. And now we are squaring it up. So it will become expected value of x square times expected value of y square. So any doubt till second step?
No, ma'am.
No?
No, ma'am.
Ma'am, can you please explain the second step?
A second step. Okay. So first step is clear, right? Now xy, if you look at the
I
first
mean,
term,
first step is the formula, right?
first step is formula. Now the
Mhm.
first term here, expected value of xy square, right? So xy square, we can write it as x square times y square, right?
Okay.
And expected value of xy whole square, second term. So if your random variable, two random variable, x and y are independent, we write expected value of x times y as expected value of x times expected value of y. Now you have to square this term. So if you square this term, it will become expected value of x whole square times expected value of y whole square, right?
Okay.
Yeah. So in the hint, we had seen that if your if your two random variable x square, x and y are independent, we will also say that x square and y square are independent. So the same thing we will have to apply in the third step here. So expected value of x square times y square becomes expected value of x square times expected value of y square because of the independence condition.
Okay.
Right? Now, look at expected value. Look at the second term here in the third step. That is expected value of x square, expected value of y square. Right?
Hmm.
So, what is this expected value of x square here? Okay, so one thing what you can do here is like
26.
Sorry,
Expected value of x square 26.
expected value of x square is 25.
No, that is square of expected value of x. I am saying expected value of e in bracket x square. I am saying that.
You are saying expected value of, okay, in
X
the
square.
bracket square is there.
Yeah, so
Yes.
we actually,
Okay, you cannot find it. Is you can find it, but you'll have to find variance of, like, what is variance of x?
variance of x.
Variance of x is expected of x square minus square of expected of x.
Square of expected of x. So from there we can find expected value of x square.
Correct. So it
We
is
can
coming
find
26.
expected
It is
value of
coming
y square.
26 and 102.
102. Yeah.
Okay, so it is coming at 26 and 102. So
Right.
you can find that term, right? So that first part is clear. I mean, the first term here, if you look at the third step, if you look at the third step, first term. So from there, you can find expected value of x square and expected value of y square using the formula of variance of x and variance of y.
So,
Fine.
ma'am, what is the difference between third and fourth? In third, it is given as expected value of x square times expected value of y square.
Fourth step, it just one term has been added. So instead of doing this, we can also do this. Just give me a minute. We'll share that.
Can't we just substitute value at third step itself? I mean, instead of.
Sorry.
Can't we just substitute values at third step itself? Like we can find expected value of x square and expected value of y square directly and just substitute in the third step.
You can do it. You can do it. This is yeah, that's long. This is a long process actually. What has been done here on the slides.
Yeah, true. After step 3 itself, we can compute the value.
Compute the values, right?
Yes.
So we know the variance of x. We know the variance of y. We can just find the expected value of x square, expected value of y square. We know expected value.
In that case, answer is coming 152, ma'am.
Answer is coming as 152. Yes, answer is coming as 152. Right.
Okay. Great.
How many of you had answered 152?
No, I have not answered. I'm just saying.
Many people here have answered 152 and some has answered 25.
152.
Yeah, so the correct answer for this question is 152.
Ma'am, just intentionally I'm asking this question. Like in case of in case of expected value, we say that if two variables are independent, then
Yeah.
it is a product of their expected value, like ex into ey, expected of y, right?
Yes.
So in case of variance, can't we say that variance of xy is nothing but variance of x into variance of y?
No, in case of variance, we cannot say that. I think in the lecture also it has been mentioned.
Sum is fine, but product is not, right?
And sum is also fine when x and y
Independent.
are independent. Otherwise,
Yeah.
in general, it is not.
In lecture, we have discussed about sum. I don't think that we have discussed about product.
Yes. So
Product of variance we have not discussed. Yes.
So what we do is, like in case of expected value, like expectation, if you have two random variables x and y, then expected value of x plus y, we say it is expected value of x plus expected value of y. Like no need of independence there. But if x and y are independent, our expectation of x times y becomes expected value of x times expected value of y. And in case of variance, only the some part is true in the case only if x and y are independent.
Okay.
Ma'am, one doubt. If x and y are independent, can we say that all functions on them are also independent? Like here, x square and y square we're taking as independent.
It is a general, yeah, you can say that.
So x cube and y cube will be independent.
Yes.
So x and y cube, will they be independent?
X cube and y cube will be independent. Maybe not always to x cube and y cube. I will have to check that part.
So we cannot always say that functions on the random variables are also independent in all cases.
Yeah, let me just check on that part. So by the time let's do the second problem and I will confirm on that. Okay.
Okay, ma'am. Thank you.
So
will these questions be shared after this
Madam,
session, or
yes,
we
the
have to?
slides.
Ma'am, can you please show the solution? I'll just take the screenshot.
Sorry, what you are saying?
In the solution, you can take just till the third step. Okay. Those last three steps are not useful. You can
Okay.
calculate your expected value of x square, expected value of y square, using the variance of x and variance of y. And from there, you can get your answer.
Ma'am,
Yeah, next slide, please.
So,
Okay.
Ma'am,
Slides will be shared with you, so please do not.
yeah. Oh, okay.
Thanks, ma'am.
Yeah, thank you. So, yeah, let's move to the next problem. So in this problem, we are saying that the joint probability mass function of three discrete random variables, x, y, and z is given to you. So basically what is given here is like the first P of 0, 1, 2. So 0 here is your x, y, 1 here is your y, and 2 here is your z. And this happens with the probability 1 by 4. The second case, your x takes the value 0, y takes the value 1, and z takes the value 3 with probability 1 by 4. Similarly, third and fourth step. So given this is given to you, now how will you find the variance of xy plus 2z? So we'll look at the solution at 6:30. By then, please try to solve it. Okay. Any doubt in this problem?
No, ma'am.
Yes, ma'am. How to calculate marginals of XYZ?
Yeah, we'll go to that. So again, we have very less responses here. So most of the people have answered is 23, as I can see, and rest are all random numbers. Okay.
Ma'am, we have to just print, just type the number, no? There's no option of entering or something in this.
Sorry.
Ma'am, I just typed the answer on that portal, but only just have to type it. No, there is no way to enter or something like that.
Yeah, you just have to type
Type it, right?
Okay. So how many of you have tried the table method here?
Ma'am, I tried it.
Okay. Can you raise your hand? How many of you have tried table method? Four. Okay. 5, 6, 7. Okay. So I could say some 9, 10 people have made the table and tried to solve it. So basically, you can see here that your random variable x is taking just two values, 0 and 1, and your y is taking some value, two values, again 0 and 1, and z is taking four values, that is -2, -3, 2, and 3. And each have those probabilities 1 by 4, 1 by 4, 1 by 4, 1 by 4. So we know, your x, y, and z, what all values it is taking, and what all the probabilities are there. So if we have to make the table for xy plus 2z, so corresponding to each x, y, and z can be if you look at the first term where x is taking the value 0 and y is taking the value 1 and z is taking the value 2. So what value of xy plus 2z is going to be? Can you just it is coming out to be 4, right? So what is x?
First.
Xy is 0 and 2z is 4. So for the first values of xy and z, your xy plus 2z is taking the value 4 with how much probability?
1 by 4.
For the second term here, your x is taking the value 0, y is taking the value 1, and z is taking the value 3. So xy plus 2z becomes 6 with probability 1 by 4. Then for the third one, your variance of xy again is 0 and 2z is -4.
-4.
So third is xy plus 2z is taking the value -4 with probability 1 by 4. And the fourth term here is your xy plus 2z is taking the value 1 minus 6, that is -5.
-5.
With probability 1 by 4. So we have the values that xy plus 2z taking is -5, -4, 4, and 6, right? These are the values that we saw that your random variable xy plus 2z is taking, and each have the probabilities 1 by 4 each.
Yeah.
So once we know the probabilities of each of the values that your random variable takes, so can we not find the expected value of that random variable? So xy plus 2z is your one random variable. We know what all values your xy plus 2z is. And we know the probabilities of each of the values.
Uniform random variable.
Yeah, there's a lot of noise in the background. Yeah. So we know the values your random variable is taking, we know the probabilities, and when you have to find the expectation, we just have to use the formula, right? So if you have to find the expected value of xy plus 2z, it is just sum over xi pi. So xi is we know -5 and pi is we know that is 1 by 4. So using the formula, we found that your expectation of this random variable is 1/4. What exactly we had to find? We had to find variance of xy plus 2z. So again, we know that variance of a random variable is given by the expectation of the random variable square minus expectation of the random variable whole square. So the same thing here, we are doing it. So in the first step, we found the expected value of xy plus 2z. And in the second step, we are finding the expected value of xy plus 2z whole square. So we just have to take the square values and probabilities we know, and using that we found that expected value of xy plus 2z whole square is coming out to be 93. Okay, is there any problem in any problem until here?
No, ma'am.
What you were saying that we are treating xy plus 2z as a variable here, right?
Yes, xy plus 2z is a random variable because it's a function of random variable xy.
Correct. So it's a variable. Yeah.
So it's the same thing that we have done previously. So we had a random variable xy, x times y, and we had found the variance of x times y. Similarly, here we have to find the variance of xy plus 2z. So we are finding its expectation, its square, square of its expectation, and then we are finding the variance. Any doubt in this problem?
Ma'am,
Yeah.
No, ma'am.
Final answer.
Final.
Any doubt?
yes, ma'am. Sorry, but I didn't gone through the lecture yet. Can you describe how we got -5, -6, 4, and 6?
Okay. So I will share you this part. You can see the screen, right?
Yes, ma'am.
You can see what I'm writing.
No, ma'am.
No, ma'am.
No,
You can see the question only.
No, ma'am.
you cannot see the red line.
No.
No. The question screen is visible. Peer tech once.
No.
Okay, wait. Yeah. Can you say this?
Yes, ma'am.
Yes, ma'am.
Okay. So see, you have x, y, and z, right? So you have your f, x, y, z given here. Now look at the first term here. So it is x taking the value 0, y taking the value 1, and z taking the value 2. Probability is 1/4. X taking the value 0, y taking the value 1, z taking the value 3. Probability is 1/4. X taking the value 1, 0, and -2. The probability is 1/4. And x taking the value 1, y taking the value 1, z taking the value -3. Probability is 1/4. Right? Now we have to look at what all values your random variable xy plus 2z will take. So I will just make another column here. That is xy plus 2z. Okay. So xy, look at the first row. So xy is 0 times 1, that is 0, and plus 2 times 2, that is 4. So it becomes 4. The second one becomes 6. Third one becomes -4, and fourth one becomes -5.
Okay, ma'am. I understood. Thank you.
Yeah. So all this we have seen in the first 2 weeks. So I hope this
Yes.
part is okay.
Yes, ma'am.
Okay. So let's go back to question number 2. I hope this question is clear to all of you.
What is the final answer, ma'am?
The final answer is what?
93/4. 93/4.
No,
No, 23.18. Yeah.
23.18.
Yes, okay. But I was not able to 371/16 I was getting. Yes, it is okay now. Got it.
Okay.
Ma'am,
Yeah.
Just a quick clarification. Like here we have treated xy plus 2z as a random variable, right? So now this is crystal clear. But say for example, this idea didn't came to my mind, and I started solving it as a normal way, right? Like variance of xy plus 2z. So I will further break it out like variance of xy plus variance of 2z, which is not but variance of xy plus 4 into variance of xz, because 2z is nothing but.
We don't know whether x and y are independent or not.
Yes, I was coming to that.
Actually, we do know that they are independent, right? Because the other probabilities are zero.
Okay.
Yeah.
Correct. And ma'am, one more follow-up question to this. Say, for example, if we are aware that x and y, z are independent, right? And if this kind of probability is given, so that can be reached out to marginal probability.
In case it was x, y and z are independent, then x, y are also independent, right?
Correct.
So in this case, we can say that variance of xy, but again, this xy and 2z are independent or not, we don't know.
Okay.
Yeah,
No,
so,
ma'am, this I got it. I'm asking a follow-up question to this. Can you come back to the table, ma'am? Can you come back to the table? The probability table is given.
okay.
Yeah, slide number 6. Yeah, 5. Yes, this is 5, right? Say for example, this kind of JMF joint probability distribution is given, right? Joint PMF is given. Okay. And if I have to find out the marginal, so is it possible? If say for example in a question, if I get this kind of table, so then can I reach out? Because with the help of two and
So what marginal you want to find here?
like px, py, pz, like in case of two random variables, we find it out that we do the summation, like keeping x constant, we sum it out over entire y. By keeping y constant, we sum it over entire x, right? So say for example, if three random variables are given, so that technique.
So you will have to keep the other two random variable constant and in like sum it over the third variable.
Madam, on the same point, is it really necessary? Because the summation of probabilities is already leading to 1. So rest of them have to be 0, correct?
Rest of them have to be 0 here, right?
So can we try the method? Because I went by the same approach as the other gentleman, but I got caught in the same thing. X and Y not knowing whether they're independent or not. But is it really applicable? Let's say somebody, this problem is slightly modified saying X, Y, and Z are independent. Can we use that method? And if yes, how would we actually approach it with finding out the variance of X and Y and Z? Is it only using the marginals?
Even if X, Y, and we are saying X, Y, and Z are independent, and you have to find variance.
Ma'am, can I complete my question? What I was trying to say.
Okay.
Yeah, of course, he just extended what I was trying to say, but I wanted to say that, say, for example, only these four informations are given, right? And I know P of X is nothing but the summation of probability of X equal to 0 and probability of X equal to 1, because my X is taking only two values, right?
Yeah.
0 and 1. Similarly, probability of Y is nothing but the summation of probability of Y equal to 0 and Y equal to Y. Okay, it's a fair point that all other marginals are 0 because the sum is making 1. So how to find out the marginals? Can you help me out after answering this question? Can you help me out with the help of these four pieces of information? Can I find out my marginal of probability of X, probability of Y, and probability of Z? If it's possible or not. If it's not possible, you can say no. So we can move to next slide.
Okay, so we'll have to find fx of 0. We'll have to find fx of 1. Then we'll have to find fx of fy
And
of.
we can't see what you are writing.
Okay, yeah, wait. So
Yeah.
so we'll have to find, if you want to find the marginal, we'll have to find fx of 0. We'll have to find fx of 1, fy of 0, fy of 1, and fz of 2, fz of -2, fz of 3, and fz of -3.
-3, right.
All this we'll have to find.
Yes.
So
this information, can we find it out here in this table?
This is a little like if you had just two random variable, then it would have been a little easier.
Much easier.
But we don't know the joint. Like how do you formulate the table here?
Okay. No, he brought a very good logic now that all other probabilities are 0, or all other marginals are 0 because all these are summing up to 1, right? all these four joint PMFs are summing up to 1. So all other marginals, all other joint PMF are 0, right?
Yeah, so okay, somebody has already answered it here. Shouldn't it just be 1/2 for x? Yeah. So yeah, for fx of 0, we see that the first row and the second row has x equals 0. And now we will have to sum it over all the y's that it takes. Right? So we are fixing x and varying our y and z. So for that cases, we have like these two values, that is 0, 1, 2 and 0, 1, 3. So what is the probability of the first part? It is 1/4. Second part, it is 1/4. So what is the probability of fx of 0? It is just going to be 1/4 plus 1/4. That becomes 1/2. So fx of 0 becomes 1/2. Similarly, fx of 1 becomes 1/2. So we'll say that x that is taking the value 0 and 1 both have the probabilities 1/2. So we can say that x is uniform 0, 1. So
Ma'am, but there's a small doubt that I have. So we don't know the other values, right? Of x taking value 0 and y taking value 0 and all that stuff. I mean, can we just assume that the probability of those are just 0?
Here.
We just have x taking the value.
0 and 1.
Okay, so we just assume that that probability is just 0.
Yeah.
Okay.
Similarly, you can try for others like fy of 0, fy of 1.
Yeah.
So should we move to the next problem? Is it clear?
Yes.
You can try for similarly fy of 0.
Yes,
So
ma'am. Yes, ma'am.
Fy of 0 will be 1/4, right, madam?
1/4. Fy of 0, it will be 1/4.
Ma'am?
Yeah.
Hello?
Yeah, please tell.
Yeah, for me, the takeout is that with the help of two variables, it is much easier to calculate the marginals. But
No, even for three variables, even you have done all this in the previous weeks.
But three variables, I think we have not done with the help of table, ma'am.
Yes, we have done.
I think there are activity problems of this.
Yeah, we have done.
You have done, right? There are some activity problem of this.
Yes, ma'am, we have done.
We have done this.
Okay.
Yes, ma'am.
Okay, so let's move to the next problem now. So the next problem we have is from Markov inequality. It says, the question says, number of people that is represented by X who make reservation in a restaurant on a particular day is a random variable. So number of people who will make a reservation in a restaurant on any particular day is considered as a random variable whose mean is 5 and variance is 4. Now you have to use Markov's inequality to find a bound on the probability that on any particular day, the number of reservations will exceed 20. So this is, I assumed it is quite easy because you just have to use the Markov inequality here. Okay, so we look at the solution by 6:55. Okay, till then just try it. If you are not aware of the Markov inequality or if you haven't watched the lecture, I will suggest please just look at the slide and like have a
this lecture in this.
This will be in the last lecture.
Okay.
So if you haven't studied the Markov and Chebyshev's inequality yet, to solve this problem, you can just look at what the Markov inequality is, what the Chebyshev's inequality is. For this problem, just look at what the Markov inequality is and try to find the bound on this probability. We'll discuss in like few minutes.
I mean, 655.
Sorry.
It's 655. You told that we will see the answer at 655.
Okay. So, okay, from 28 responses we have received. Oh, we have two answers like B and D. Most of the people have said B or D. Okay. So, what is the correct answer here?
I think it's B, ma'am, because it is less than equal to. So at most will be the right one.
At most will be the right one.
Yes, sir. Because as per
Yeah.
Markov
And the
inequality,
number of
the
reservations
probability,
that exceeds
the probability is less than equal to mu by c. Less than equal to mu by c. So when we say less than equal to, it means at most.
Yes, we are talking about less than equal to in case of Markov inequality.
Yes.
Not exactly that. I mean, if you are just given the mark, like if it just says use Markov inequality, then we can also take it the other way, like other inequality, and do the minus sign, one minus thing. But here it says find a bound on the probability that on a particular day, the number of reservations will exceed 20. So the number of reservations were denoted by the random variable x. So basically here we want to find the probability that x is greater than 20, right?
Yes,
So
we are saying that
x
it is greater
so
than equal to 20.
So if x greater than 20, probability that x greater than 20 will be the bound that will be given on this will be less than equal to expectation of x by c. So in this case, it becomes at most 5 by 21. So
D option, right?
We look at the solution. So using Markov inequality, this is what we say, that any random variable x that is less than equal to c will be less than equal to expectation of x by c, where here in this case mu is denoted as expectation of x. Now we have to find exceeds 20, right? So exceeding 20 means we are talking about that x should be greater than equal to 21 because it is a discrete random variable, right? So saying that probability that x exceeds 20 means we have to find probability that x is greater than equal to 21, right? And using Markov inequality, we know that this will be less than equal to expectation of x divided by 21. Expectation of x is given to us, that is here 5, right? So it's just going to be 5 upon 21. Is it clear to everyone?
Ma'am, why you are saying x is greater than equal to 21?
Yeah, because using Markov inequality, you see that both greater than equal to term comes. So if I'm saying it exceeds 20, it means it is greater than 20, right? X is greater than 20. So it cannot be equal to 20. It can be greater than equal to 21. It can be either 20 or greater than that. Since a discrete random variable, right? We are dealing with discrete random variables here.
Okay.
So using Markov inequality now, this term is going to be less than equal to 5.
Hello, ma'am.
Yeah.
Hello.
Yeah, this 5 by 21 is clear, okay. But how come the answer is B? Because it is at most, na? At most, not at least. The option 4 talks about at most.
Option 4 talk about,
at
so
most.
5 by 20.
Okay, so at most 5 by 21, yes.
5 by 21, okay. So that was the issue here. It was not at least or at most, it was 5 by 20 and 5 by 21 part. So your correct answer is B.
At most, how it is defining here? That it is at most?
At most, okay. So if you look at the Markov inequality, right? So the first statement, so this is less than equal to C. So this probability, right? Probability that x is greater than equal to C should be less than equal to mu by C. It means this mu by C is your upper bound here. it cannot be more than mu by 6c. Right?
Okay.
Whenever we say it cannot go beyond a further point, it means that is our maximum that we are assuming. So that is at most. It can go at most till mu by c. It can be less than mu by c, but it can go maximum till mu by c. And if we are saying that, and when we say at least, we use the at least when the value it takes is at, let's say I'm saying probability is greater than equal to a. So that probability should be like the minimum that it can take is a. It can be greater than a. The minimum that it will take is a. So in that case, that context, we use the term at least.
And for at most, we take
So
greater
at
than.
least and at most, you will encounter a lot of these words like at most, at least, lower bound, upper bound,
Yeah.
in Markov and Chebyshev's inequality.
Okay.
So since it was less than equal to, we are saying it is at most here.
Oh.
Okay.
Thank you.
Yeah, thank you. So we'll move to the next problem. So it's the same continuation from the previous one, but in this case, you have to find a bound on the probability using Chebyshev's inequality. So what do you have to find exactly here? It's like, look at this last sentence here. It says, find a bound on the probability that on a particular day, the number of reservations made will lie in between 1 and 9. So you have to find that probability that X lies between 1 and 9. So what is the bound on that probability? And you have to use Chebyshev's inequality for that. So again, if you are not aware of what Chebyshev's inequality is, please go and check the formula first and just try to solve it. Like
I
if you
posted the link of the formula. So,
you can check on the slides, go to the portal and check the slides. It is there.
Ma'am, the same is available in the notes as well. They can download the notes and check.
Yes, notes are also available from week 1 to 4. So for any formula and all, you can just use the notes and it will
Only till week 3.
Only till week 3 it is uploaded.
Yeah, I just saw it now.
But this is week 3 only, no? So we can check that. I am checking that one only.
Yeah.
Okay, so whatever it is, just do it for now. We'll discuss by like it may take some time for you to solve this problem. Let's wait till let's give some 5 minutes and then we can discuss. Okay.
Ma'am,
Yes.
ma'am, in that Chebyshev formula, what is the value of K? I'm not getting. It's written that
K you are not getting. Okay.
K into sigma.
So can you try to read the statement of Chebyshev's inequality and try to relate what K can be?
Okay, let me.
Just sit with the what the inequality is. Try to do some maths there. It is. I am sure you'll find out. Just give it some more time.
No, ma'am, unable to compute K.
Okay, so we have received some 26 responses for this question. Okay, let me see. So most of you have answered option C. Majority of you. Okay, let's see what the answer is. So C is the correct option. So it is at least 3/4. Okay, I will solve it somewhere else. Can you see this slide?
No, ma'am.
Can you see it now?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay.
Ma'am, sigma square is the variance of that
Sigma
thing,
square
right?
is the variance of X, right?
Yeah, but I think that's right. It was written sigma equals.
Yeah, so okay. Here your random variable is X, and the mean of X is given to you, that is 5, and variance of X, that is sigma square, is given to you as 4. Now using Chebyshev's inequality, we know that probability mod of X minus expectation of X greater than some K sigma is less than equal to 1 upon K square, right? This is what we know. So if you look at this inequality, it says this is mod of X minus mu greater than K sigma is less than equal to 1 upon K square. So look at the inside term. It says X is greater than K sigma plus mu and X is less than mu minus K sigma, right? So if you draw, if let's say if this is our mu, then this can be your mu plus K sigma and this can be your mu minus K sigma. So probability that your X is greater than mu plus K sigma and X is less than mu plus K sigma, this probability is less than equal to 1 upon K square. But what do we have to find here? We have to find a bound in the probability that on any particular day, the number of reservation made will lie between 1 and 9. Okay, so this is not what we have to find. We have to find this inside interval, right? This inside part. So this should be your 1 and this should be your 9. So if this probability is given to you, how will you find the inside one? You'll just do 1 minus, right? Is it okay?
Yes.
No.
So okay. So instead of writing this, if I write, can you mute? Yeah. So instead of writing this, if I write P of mod of X minus mu less than equal to K sigma. So this becomes greater than equal to 1 minus 1 upon K square.
Yes.
Is this okay?
Hmm.
You have seen this in the lecture also, this inequality that I've just written here.
Okay.
Right? So now if I expand this, so it basically gives your X that lies between mu plus, sorry, this is mu minus K sigma and mu plus K sigma, right? So this mu minus K sigma in this case should be 1 and this mu plus K sigma should be 9. Now let's solve this. If I solve this, I will get 2 times mu. 2 times mu equals to, okay. So we'll get 2 times mu equals to 10. So mu becomes 5. Mu we know it is 5. Sorry, mu we already know it is 5. We just have to find K, right? We can use no need of this. Sorry. So mu plus K sigma should be 1. Should be 9. We know mu is 5. It is given to be 5 and sigma square is given to be 4. So sigma will become 2. So this 5 plus 2K equals 9. So what will K become? Just 2, right? K will become 2. Now, in place of K here, just substitute 2.
1/4.
Right? So it will become probability mod of X minus 5 less than equal to 2 sigma. So where sigma is again 2. So this is 2 times 2 is greater than equal to 1 minus 1 upon what is K square? K square will become 4. So 4 minus 1, this is going to be 3 by 4. So again, this probability should be greater than equal to 3 by 4. So probability is greater than equal to 3 by 4. It means we are talking about at least here. Right? So the correct option will be 3.
Ma'am, can you explain a bit on lower bound?
Okay. So
how you came to know that it's at least or at most?
Sorry, how to?
That it's at least or at most.
Okay, so what we got here is we got that probability. Let's say this came out to be P, some small p. This P is greater than equal to 3 by 4. So it can be any number between 3 by 4 and 1, right?
No, ma'am, that I understand. But from question, how you came to know that it will be at most or at least?
No, from question, we are not saying we know it is at least or at most. We solved it and we are saying that it came out to be at least 3 by 4.
Okay.
From question, it is not clear that it is at least or at most. Is it clear to everybody? Like, how did we solve it?
Ma'am, there's something I don't understand. When we are doing here P modulus x minus 5 less than equal to whatever, here aren't we taking also, taking the value of 1 and 9 also?
Yeah.
It's saying will lie in between 1 and 9. Does that mean 1 and 9 included?
Between 1 and 9. Yeah, so in this case, yeah, we can say it is 1 and 9 included. So whenever we are saying 1 to 9, we are saying it is included.
Ma'am, as per inequality, when we are discussing on the greater symbol, like outbound probability.
Okay.
So in that case, boundaries are included. So when we are going to reverse it, like doing 1 minus probability, then I think 1 and 9 will be excluded out of that.
Okay, let's
That is
try to do this derivation. So we knew that probability mod of x minus mu greater than equal to k sigma is less than equal to 1 upon
k square.
Now, what we want to find is probability mod of x minus mu less than. Okay. Yeah, right. You were right there. So we are not including this. Because if you do this, this should become 1 minus probability mod of greater than equal to k sigma here.
thanks, ma'am.
So the boundaries are not included, right?
Boundaries are not included. It lies between 1 to 9.
Yeah.
So somebody had asked for more session on Chebyshev's and Markov inequality. So we can have that session tomorrow. So I know in week 3, most of the part should be clear, like expectation variance, but it can be a little problem, I understand. So tomorrow we'll mostly focus on this inequalities.
Madam, I have a question on this. If it is x greater than 1 and less than 9, we are saying 5 minus 4 and 5 plus 4. If it is 8, will it work? Just trying to see that.
If it is 8.
It's just that accordingly the k will change, right?
Sorry?
1.6 sigma.
Accordingly, the k, just that the k will change, right?
K will change. And if you want to find for 1 and 8, then one of the equation will not satisfy for you. You will have to change your lower bound also accordingly, because it is mu minus k sigma and mu plus k sigma.
Yeah, so we'll have to split it into lower, mu and mu minus k sigma and mu plus k sigma. Should we do it 2 separate terms?
You have to separate term, mu minus k sigma and mu plus k sigma.
Okay.
Yeah.
Ma'am, this at least and at most is confusing now. Now you said it is at most 3, 4. Give me a situation where it will become at least 3, 4.
At least, sorry, can you repeat? At least and at most is confusing.
Yeah, because from this equation, there's at least I'm not able to make sense out of why at least at most.
So basically, if I'm saying at least, right? So let's say I'm saying P is greater than equal to some number, let's say 0.5. So it is saying P can take any value greater than or equal to 0.5, right? So the minimum value that P can take is 0.5. So this becomes your at least. Okay. Now, the moment I say that P is less than equal to 0.5, it means that P can maximum value that P can go to is 0.5. It should be less than, it can go anything beyond like lesser than 0.5, but it cannot go beyond 0.5. So this becomes like, in this case, we say P is like, it is at most 0.5, because maximum it can go to at most, right? Maximum it can go to is 0.5. This is at least. The minimum the P can take is, the minimum that P can take is 0.5. Look at this least and most word. So whenever we're saying least, right? So least means this is the minimum value that your P can take. If we are saying most here, at most, so this is the maximum value your P can take here.
Yeah, but how to apply that one here when we got an answer 3 by 4? How does the 3 by 4 is the utmost?
How 3 by 4 is at most here? Because at least here, because we got that P is a probability that mod of x minus mu greater than k sigma is less than equal to 3 by 4. This is what we got, right?
Greater than or equal to 3 by 4.
So if I'm saying, let's say this is what, this is just the probability. Let's say this, I'm saying a small p. So the small p is greater than equal to 3 by 4. So it is at least the minimum value that the P can take, probability can take, is 3 by 4. It cannot take the value in between 0 to 3 by 4. I mean, less than 3.
If the inequality is lesser or equal to, then it becomes at most, is it?
Less than, yeah, it becomes at most.
Okay, so you're taking reference to the inequality and then wording that as at least or at most, right? Okay.
So we'll discuss more on this tomorrow also. I know it can be a little confusing at this time. So we'll discuss more about this Markov and Chebyshev inequality tomorrow.
Timing, ma'am?
Our timing
6 to 8, I think calendar has been updated. Ma'am, 6 to 8.
Calendar has been updated till your.
Yeah, 6 to 8. 6 to 8.
Ma'am, can you please discuss it day after tomorrow, ma'am?
Day after tomorrow session is not scheduled, right?
Ma'am, please take tomorrow, ma'am.
Tomorrow only, ma'am.
Actually, we haven't done that, ma'am.
It's meaningful tomorrow only, ma'am.
Tomorrow there is a submission. There is an assignment submission. Is that extra activity?
Assignment submission is on 29th.
No, it is 27.
It's an extra
No,
activity.
date change. Date change 27, no 29.
It's for your convenience. Like if you want to do it, you can do it. So
yeah, if it is 27th, then
We want to do it. That's why we are.
Ma'am, we can. We want to do it tomorrow.
stop the discussion. So tomorrow there's a session. So we will discuss the week 3 content. All of you who couldn't join the session, you can watch it later on YouTube. So that should be fine, I guess. Now let's move to the question here. So here we have split the questions in 2 parts. The question basically says you have a lottery and it has 1,000 tickets. And out of those 1,000 tickets, only 2 tickets contain prizes where the price of 1 ticket is 1,000. I mean, the price worth, right? So 1 ticket has 1,000 rupees price worth and the second ticket has 2,000 rupees price worth. And all the other remaining 998 tickets, like if you choose those, you will get the price 0. You're not getting any price. Now, so the random variable x represent the worth of the ticket. So worth of the ticket basically I represent like if you buy a ticket, what is the price that you're going to get? Now, suppose you have bought, the first question says, suppose you have bought 2 tickets, then find the set of values the random variable representing the worth of the price of 2 ticket takes. So if you are buying 2 tickets, so what all prices, what are the possibilities of the like ticket worth you can get? And similarly, the second question, if you're buying 3 such tickets, what are the set of values your random variable will take? So these are not very tricky question. Let's just stick to just some 2 minutes, then we'll discuss this. So you can write your answer. There is an option to write a response. You can write the answer for one and answer for two separately.
How to join this?
How to join this? Okay, go to
Answer.
join.com and use the code on the top right of the screen.
Okay.
Okay, so let's see the solution.
Do we have to take a set of values or do we have to?
Yeah, set of values. Okay, so so many people have answered for just one problem. I could see most of them are right. Okay. Okay, so the first problem you had is like we had bought 2 tickets, right? So out of 1,000 tickets, we have 2 tickets of prices worth rupees 1,000 and 2,000. And if we are buying 2 tickets, so either we can have both tickets of price like whose worth is 0 rupees, or we can have 2 tickets where one ticket is of worth 0 rupees, or other can have 1,000. Or we can have 2 tickets where one ticket is worth rupees 0 and other can be rupees 2,000. Or we can have one of 2,000 and other of 2,000. Sorry, 1,000, other of 2,000. So the set of values that your random variable can take here is either 0 or 1,000 or 2,000 or 3,000. So these are the values that is possible.
And how 3,000?
How 3,000? So you have to basically sum, right? Now you have 2 tickets. You have bought 2 tickets, and in case you got one ticket of worth rupees 1,000, other of worth rupees 2,000, then you have tickets of worth rupees 3,000.
Okay, worth. Okay, sum. Okay.
Okay. So similarly, in the second problem, you are, instead of buying 2 tickets, you are buying 3 tickets now, right? So if you are buying 3 tickets, again, the possibilities we can have is 3 tickets can be of the worth 0, 2 tickets can be of worth 0, other can be of worth 1,000, or 2 tickets can be of worth 0 and other can be of worth 2,000, or one ticket can have worth 0, another can be of 1,000, another can be of 2,000. So again, in this case, the set of values that it will take is the 0, 1, 1,000, 2,000, and 3,000.
And
yeah.
Here, random variable has been
Yes.
defined as the worth of the ticket, right?
Yeah, worth of the combined ticket. That ticket.
Combined ticket or worth of a ticket?
No.
No, worth of the combined ticket.
Can we go to question?
Okay, wait. Worth of
Let the
the
random variable x represents the worth of the tickets. No, in question, let the random variable x represent the worth of the tickets, right?
Yeah, right. So
irrespective of the fact that whether I buy 3 tickets or 4 tickets, my random variable will take only 3 values, and that is 0, 1,000, and 2,000.
0, 1,000, and 2,000.
2,000. My random variable will take only these 3 values.
Just either 0 or 1,000 or 2,000. That is right.
Correct.
Yeah.
So then how?
Yeah, but the first question was like, now your random variable is taking just 0, either 0 or 1,000 or 2,000, right? Now the first question says you have bought 2 tickets from there. You have bought 2 tickets, right? So if you have a set of 0, 1,000, 2,000, and you have bought 2 tickets from there, so the combined worth that it is going to take is either 0 or 1 or 2 or 3,000. So representing the worth of the prices of 2 tickets that it takes. Right. Similarly, in the second one, it is 3 tickets. So it was just the problem is something else. So we'll go back to the problem now. Okay. So till here it is same, and here first thing that you have to find is find the so x can be a little confusing here. X is now a different random variable. We should have said it is y. So just a small correction. Instead of the random variable x here, it is now random variable y. So that represent the worth of the prices of 2 tickets. Okay. So what is the probability that this y is taking the value 0? What is the probability that y is taking the value 1000? And what is the probability that y will be 1000? So you can
So
again,
instead of x, it is y.
sorry, yeah, because it is the combined worth we're talking about here. Yeah. So can you just find the values like of probabilities? So here what x equals 0 means is like the 2 tickets you have got, their combined worth is 0 rupees. Second problem, the 2 tickets that you have got, their combined worth is 1000. And the third ticket that you have got is their combined worth is 3000. This is what you have to find.
In this case, it's just the 2 tickets, right?
Yeah, 2 tickets. Just
Okay.
okay. So please try to find these probabilities, and we'll discuss in 2 to 3 minutes. Okay, so let's move to the solution part. Okay. I could see a lot of variations in the answer. So for the first part, most of you have answered 0.99. And okay, let's see. So if we have to find probability x equal to 0, it means we wanted to find the probability that both the tickets, the two tickets that you have got, the combined worth is ₹0. So those two tickets should come from those 998 ticket, right? Out of those 1,000, out of those 1,000 tickets.
Yeah.
Right? So basically it is 998 by 1,000. So it will become
Yes.
0.998.
8.
First is 0.998. So first is mostly right for all of you. Second one says is their combined worth should be 1,000. So their combined worth can be 1,000 if only if one ticket is 0 and other ticket is 1,000. So one ticket should come from those 998 tickets, and other ticket should come from those two tickets, right? I mean, no, sorry, just one ticket, because 1,000 is just one ticket. So it should be 998 divided by your 1,000 choose 2, because you will have to select two tickets, right? You have to select two tickets out of 1,000,
Yeah.
where one ticket should be 998 and others should come from one. So 998 choose 1 times 1 choose 1 divided by 1,000 choose 1. I don't know what you will get after you solve this. So 998 times 2.
0.0019.
0.10019. Yeah. So I think even the second answer was right for most of you. 0019. I didn't calculate it here, but yeah.
Ma'am, it's coming out to be 0.996.
Right. Yeah, what?
Ma'am, the answer is coming out to be 0.996.
It is not very clear. Can you repeat again?
Ma'am, the answer is coming out to be 0.996.
0.996.
Yes, ma'am, exact answer, which is.
Okay, wait. So
0.996 is for the x when x
0.998.
oh wait, let me just calculate here. I haven't calculated. Okay.
Can you write on the screen as well, ma'am?
Okay, I will write it on the screen.
You are calculating for first answer or second answer?
No, we are calculating for the second answer.
0.02.
0.02 it is coming.
0.002.
0.0019 something.
Yeah.
So okay. So
0.001.
first part x equal to 0, it means it should come from those 998 tickets. So
Yeah.
it's 0.998. The second part, it should one should come from this 998. 998 choose 1. Other should come from those one ticket. So basically it's 998 on 10,000 choose 2. So 10,000 choose 2 will become, sorry, 1,000 choose 2 will become 1,000 into 998. So 990.
It's
992.
499500.
What does it come?
Ma'am, it comes to 998 upon 499500.
Ma'am, zero.
0.00199. It's come like
Yeah,
that.
so this will come out the answer.
Right, ma'am.
Okay.
And similarly, the third one is
Ma'am, I have issue in third one because it's coming 1 upon that 1000 C2.
yes, it will be 1 upon 1000 C2.
It will be.
Because you have to you have to select 2 tickets. So divided this denominator, it should be 1000 choose 2. But in the numerator part, like the 1000 will come only if one is 1000, other is 2000. That is fixed. So that's why it become 1 divided by 1000 choose 2.
And that 1 is coming because of 1C1 into 1C1, right?
Yeah, basically 1C1 because you have just one
Correct.
1000
Yes.
and one
Yes.
2000. So there is no selection. No, this is fixed. Only.
Yeah, so 1C1 into 1C1. So that is
Yeah.
clear.
So you can just solve it and see what the final answer is.
I mean, third it is, I think, 2C2. No?
Not even 2C2 will come out to be 1 only, no?
1
2
only.
is 1. So it will be 2 divided by 1000 into 999. You can calculate this to get the third answer. Okay.
First one is 998 choose 2, right? Divided by 1000 choose 2.
Yeah, so again this 2 and 2 is getting cancelled out.
Yeah, so 998 into 997 by 1000 into 999.
Yes, ma'am.
No, it will be 999.
Okay. Yeah, I think I did the mistake there. Yeah, 998 choose 2 means 998 times 997 divided by 2. Yeah, you're right. I made a mistake. Into. So this will be your answer.
Okay, ma'am.
Almost come out to be same, I guess.
Yeah, 0.996.
It should be very close, I feel.
Yes.
0.96.
0.996, yeah.
Ma'am, it is close, but just the 0.001, my 8 question is pending for graded 2.
Sorry, which is pending?
Ma'am, in graded 2 assignment, week 2 assignment, I raised one query of question number 8.
You raised one query on question number.
Ma'am, could you just show me the final answer in this?
Yeah.
I will share it. Yeah, you can calculate this. I haven't calculated. You can calculate and.
Oh, we don't have final answer.
So, okay, so we'll move to the next part. So in this case, it's just the continuation. Now you have to find like what should be the expected gain. I assume if we have solved all this, it should not be very hard. Yeah, so what question number are you talking about in week 2? Sorry.
Ma'am, it was question number 8.
Question number 8.
From week 2 graded assignment.
Okay. Okay. Have you put it on discourse?
Yeah, ma'am, I put it on discourse, and you replied it back that you will be looking out and will sort out.
Okay. 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 Fine. I will check it again.
Right, ma'am.
So for now, please solve this problem. So I will just 1-2 minutes will wait, and then we'll continue.
Ma'am, we have not calculated in the previous one the probability of the total winnings being 2000, right?
No, we haven't calculated. Now you have to find it expected.
That also, yeah.
Please do it. Okay, so for this problem, let's see the responses. So many of you have answered, it looks like 6, and rest varies a lot. Okay. So the explanation for this problem, like we had already seen what all values, like what should be the worth of the ticket when you are buying two. So X was either taking the value 0 or 1000 or 2000 or 3000, right? So also we have found their probabilities. We just found the probability of X equals 0, X equal 1000, and X equal to 3000, but we did not find the probability when it is taking the value 2000. So that is also going to be same as probability that it takes the value 1000. So once you calculate these values, you will just have to multiply the values along with its probabilities. So we find the expectation. You will get 0 times 998 choose 2 divided by 1000 choose 2 plus 1000 times 998 choose 1 by 1000 choose 2 plus 2000 times 998 1 divided by 1000 choose 2 plus 3000 times 2 choose 2 divided by 1000 choose 2. Once you solve it, you will get the value 1 upon 6. Sorry, 6. Just 6. So the correct answer is 6 here.
Ma'am?
Any confusion in this? Yeah, tell.
No, it's fine.
Sorry.
So one ticket in case of 1000, right? So one ticket is coming from 998, right?
In which case? Which case you're talking about?
The first bracket, 1000 multiplied.
998 divided by 1000 choose 2.
998 is for 0 case, right? For 0, like 998 C1 is for 0. Like for only there's only 2 cards with 1000 and 2000. The rest are zeros. So
I think they have not put one term that one C1, because one ticket will be coming from the ticket which worth rupees 1000, right, ma'am?
Yeah, so 1 choose 1 is nothing but
correct, one. Yes. Okay.
Is it clear? It is continuation from the previous problem.
Yes, clear.
So the correct answer is 6 here. So we have already reached 8 o'clock. So there was one more problem. I'll just quickly say it. I will take just 10 more minutes. So the next problem is, okay, you have a share of a company costs rupees 100 today. So let's say today the share of your of some company, per share the price is 100 rupees. Now, if today's share price increases by 50% with probability 0.5, and when it decreases, and let's say it decreases by 20% with probability 0.5. Independent of today, suppose that tomorrow's share price increases by 30% with probability 0.6 and decreases by 20% with probability 0.4. So if you decide to buy 3 shares today, what should be your expected profit at the end of 2 days? So you have today's share price, like what all the possibilities the share price can go to. So one possibility is like today's share price can go either increase by 50% or either decrease by 20%. So independent of what happened today, let's say if it increases, then on the second day, again, it can either increase or decrease. And let's say if it decreases today, again, in the second day, it can either increase or decrease. All the probabilities are given to you, and by what proportion the values are increasing or decreasing are given to you respectively. So if you decide to buy, let's say 3 shares today, what should be your expected profit at the end of 2 days? So I have already received one response here. I'll give some 5 minutes to solve this problem. Yeah. Let's try this problem.
Ma'am, can you send me the PD link?
Join PD link. Go to joinpd.com. Go to joinpd.com and use this code that you are seeing on the top right corner of the screen. CEN MRM. Go to joinpd.com, Google it, joinpd.com, and type this code there. You will see this screen.
Ma'am?
Yes.
Yeah, just like, independent of today, suppose that tomorrow's share price increases by 30%, right? So
Yeah.
what base should I take? Should I take 100 or what base should I take here?
No, so what it's saying is like
independent of today, right?
Okay, so today it can either increase by 50% or it can also decrease by 20%, right? So if
Correct.
increasing by 20%, if it is increasing by 50%, tomorrow again, let's say I'm assuming that it increases by 50%. So if it
So
increases by 50%, it will go to 150 at the end of the day, right?
Okay, so
for
I have to consider.
tomorrow, yeah.
So the base 150 will become. Base
Yeah,
will become
150
150.
will be coming, and then on 150, either again it can decrease or increase on the second day, right? So you have to think like that. So let's quickly go through this problem here. So many of you have answered 81. So the problem statement is clear to all of you. Is the problem statement clear?
Yes.
So,
Ma'am, can you explain the problem once more?
yeah, wait, I will stop sharing this. I will just write it over here. Okay. So, what does it say is like today a company share, a share of a company cost 100 rupees per share. Okay. And at the end of the day, we are saying it will increase by either 50%. So what is the probability given?
0.5.
0.5.
0.5.
Okay. So with 0.5 probability, it will increase by 50% and it will decrease by 20% with 0.5 probability, right?
Yeah.
Now, if it happens, let's say if it increases by 50%, So at the end of the day, the price of the share can go to 150, or at the end of the day, price of share can go to rupees 80. Now, independent of what happened today, either the next day price can either increase or decrease, and the price can either increase or decrease. So on the next day, how much it is increasing?
30%.
30% increasing with probability
0.6, ma'am.
0.6.
0.6.
And decreases by what percent?
20% with probability 0.4.
Okay. So 30% increases with probability 0.6 and 20% decreases with probability 0.4. Now, at the end of the first day, if it increased by 50%, so the price of the share at the end of the day becomes 150. Now, assuming that the first day price have increased to 150, the price at the end of the second day, if it increases by 30%, how much it will become?
195.
So
195.
percent is
195.
195. And similarly, if it decreases by 20%, how much it will become?
120.
120. Right? And what about if on the first day it decreases by 20% and the price of the share at the end of the day becomes rupees 80? So if it increases by 30%, how much price is?
104. 104.
104. And if it decreases, how much it is?
64.
64.
64.
So at the end of the day, at the end of 2 days, my price can be either 195 or 120 or 104 or 64, right? So let's take this random variable to be x. So 195, 120, 104 and 64. So with what probability the price is going to be 195? So 100 is becoming 195 at the end of 2 days. If first day it increases by 50% with probability 0.5 and second day again it increases by 30% with probability 0.6. So since it is independent, this this increment or decrement is independent of each day, even the probabilities will get multiplied. So this 0.5, this will become, the probability will become 0.5 times 0.6, 0.5 times 0.6 with for 120, it becomes 0.5 times 0.4. For this 104, it becomes 0.5 times 0.6 again, that is 0.3, and it is 0.2. Once you get this, you can easily find the expected.
Ma'am, can we check the probability of 104? Yes, 0.5 into 0.6. Yes, yes. Okay, okay. 0.5 into 0.6. Yes, okay.
So this is these are the values that you can get with these probabilities. Now, what should be? What do we have to find? We have to find expected profit. So what is the expectation first? What is the expectation of x that we will get? So we'll get 0.3 times 195 plus 0.2 times 120 plus 0.3 times 104 plus 0.2 times 64. So this is what you are getting at the end of 2 days. Now, if you have to find the profit, so on the first day, if you have bought just one ticket, it is going to be for 100. If you're buying 2 tickets, it is going to be for 200. If you're buying 3 tickets, you're going to be for 300. So whatever, so in this problem, we have bought 3 tickets. So we have spent some 300 rupees at the beginning. So whatever amount you will get here, let's see if it is less than 300 or greater than 300. On the basis of that, just decide whether it's a profit or a loss. So many of you may have a different approach to solve this problem. So if you're getting the right answer, it is all right.
Ma'am, I was trying to find out the expected value for day one itself, like, you know, when it is 100.
Many of you will try to do that. So even in that case, you will get the same answer. I will say, like, do it completely. See whether you got the
and then for day two, I was considering these two cases separately. Like considering 150, I was considering 195, 120, and then 80, 100 not 104 and 64. So in that case, I was taking probability as given, like 0.6 and 0.4. So whether that approach will work or not.
Can you try it out? Can you try it out?
Okay.
Yeah, just
And what's the final answer?
the final
should be multiplied with 3 or not, ma'am?
Let me see the final answer.
Because we are taking 300 rupees kind of thing.
Yes, you have to multiply by 3.
That was we are finding for just one, so you'll have to
Be inside it, right? Always.
So final answer is
Whichever will lie outside that, that will be the outside of that space. Suppose I am taking R to be -2, and natural number is
mute. Oh, please don't watch 2 sessions at the same time. Yeah. So the final answer that you're getting here is 26.5. So I will share the slides with you. You can check
this
on.
is for one share, ma'am. This is for one share.
Yes.
So for 3 shares will multiply.
3 shares.
Multiply by 3.
Okay, this is for one share, right? So if you
Yes.
multiply, you will get 79.5.
Yes.
79.5. Yes.
79.5 right answer. Yeah. And somebody had asked whether if 2 random variables that are independent, x and y, if they are independent, their functions will also be independent. So the proof part is a little complicated. We cannot go to that. So, but you can keep that in mind. Like if x is independent, x and y are independent to each other, then any function of x, that is, let's say gx, and any function of y, that is fy, they will also be independent. So I'm not.
Ma'am, you just need one more clarification. Like 2 functions will be independent, right? But say, for example, x and y are related to z as z equal to x plus y. Can you write it down, ma'am, please? Z equal to x plus y.
Oh, z equal x plus y.
Right. So x and y are independent, right? So now this is a function z equal to x plus y. So my g is also a random variable, right?
We are not saying that. We are saying that if x and y are independent, then any function of x, let's say gx, and any function of y, let's say fy, they should also be independent.
That is clear, ma'am. I have one more doubt. Like now, g is related to x plus y, right? G is defined as x plus y, right?
Okay, yeah.
So g is also a random variable.
Yes.
G is also a random variable. So can I say that g and x are also independent, and g and y are also independent?
No, you cannot say that.
Yes,
You
that was my question.
You cannot say that.
Thank you. Ma'am, just one small activity question, ma'am. It will not take more than 2 minutes. 3.7 question number 7, ma'am. Just need one guidance.
We cannot do. You can put it on discourse also, because here you have to close this.
Ma'am, I have one request. If you put this slide on the portal, please don't erase what you had done, the rough works.
Okay, you want me to put these slides? Okay. Okay, fine. We'll put this slide. Not the previous one. We'll put the slides.
Okay, ma'am. Thank you.
Thanks, ma'am.
Please don't erase your writings.
Yeah. Okay. I will upload the same one.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am. Okay, regarding that graded assignment.
Thank you, ma'am.
Yes, ma'am.
Okay, who had asked?
Ma'am, Ashish.
Ashish. Yes, Ashish. So your answer was not right. The range that is provided in the assignment, right? It is correct. Your
Ma'am,
answer.
it was from 0.129, but
No,
mine.
the answer is coming out to be 0.130 something. I had solved that problem, and the answer that I got was in the range.
I mean, in that case, what are the values we should take? Because I took only till 3 decimals.
It had asked till 3 decimals, right?
Yes, ma'am.
Yeah.
So I took only all the values till 3 decimals and wrote.
The answer was coming out to be something 0.130, 0.131. So it was in the range.
Ma'am, I will put the answer in Discord also. Please have a look on that first.
Okay, I will put it there. Thanks.
Sure.
Thanks all for joining. So I will upload this slide. You can have a look on the portal. Okay, bye all. Good night.
Hi, ma'am. Good night.
Thank you, ma'am.